Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let's move to the mathematical part of this topic, equilibrium, which is solving the equilibrium problem. So there are several types of the equilibrium problem that we'll get in the question. Okay, the first one is when the equilibrium quantities are given and we have to calculate our K. And the second type of the equilibrium problem is when the initial quantities and the K are given and we have to calculate or to determine the equilibrium quantities or the amount of the reactants and product at the equilibrium state. Okay, so basically when we want to solve the equilibrium problem, we'll always construct our ice table. Okay, so this ice table is to relate the initial, the changes, and also the equilibrium concentration of all components that presents in our equation. So let's look at to the first sample problem. Okay, the first example, okay, in a study of the hydrogen halide decomposition, okay, in the volume of 2 liter and the amount of the HI gas is 0.2 molar, and it is proceed by this equation 2 HI gas produce 1 H2 gas plus 1 I2 gas. And another information that is given in the question is the concentration of the HI at the equilibrium is 0.078 molar. So we have to identify, okay, the important information that we get in the question. Okay, so firstly we have the volume of the container, which is 2 liter, and then we have the initial amount of the HI, and then we have the equation, of course, and the temperature, and lastly the most important information is the concentration of the HI at the equilibrium is 0.078 molar. So to calculate the Kc, we have to have the concentration of all at the equilibrium first. So we have to construct the ice table and calculate the initial concentration of the HI. So the initial concentration of the HI initial is equal to 0.2 mole divided with the volume of the container is 2 liters, so we'll get 0.1 molar. And then we construct the ice table. So our ice table is 2HI H2 plus I2. Concentration initial for HI is 0.1 molar, H2 is 0, I2 is 0 because initially in the container we just fill in it with the reactant, which is HI, and then the concentration changes. So since that when we look at to the coefficient of the HI here is 2, so the changes will be negative 2HI, and for H2 it is increased, so it is positive X because of 1, so plus 1X, 1 coefficient for I2, so plus 1X as well, and the concentration at the equilibrium will be for HI is 0.1 minus 2x, for H2 x, for I2 x. So this is what we call as the ice table. We have I, C, and E. The concentration initial, concentration that is changed, and the concentration at the equilibrium. Next, we have to solve X because we want to calculate the Kc value. Okay, to calculate the Kc value, we have to have the concentration of all components I2, H2 and HI at the equilibrium. The only information that we get in the question is the concentration of the HI at the equilibrium. So this part is solved. So we can get the value of X, which is the same as the concentration of the H2 and I2, by solving it using the concentration of the HI at the equilibrium. So concentration of the HI at the equilibrium is equal to 0.078, which is equal to this 0.1 minus 2x. So we'll get our x is equal to 0.011. So that the concentration of the H2 is equal to the concentration of the I2 is equal to 0.011 molar. These are their concentration at the equilibrium. So now we can calculate our Kc. Always start with their expression is equal to H2 power of 1 I2 power of 1 over concentration of the HI power of 2. Plug in the value. H2 is 0.011, multiply with 0.011 over the concentration of HI is 0.078 power of 2. Then we'll get our Kc value is equal to 0.02, the same as this. Let's move to the second example. So we have a reaction of the methane and H2O to produce carbon monoxide and 3H2. Look at to the important information that we have in the question. We have a volume of the flask 0.32 liter. And then the temperature is 1200. We have the amount of the CO, 0.26 mole of CO, and then we have 0.091 mole of the H2. We have 0.041 mole of CH4. So the question asks us to calculate the concentration of the H2O at the equilibrium. So the amount of the CO, H2 and CH4 that is given is the equilibrium amount, and the Kc also given. So to solve this problem, firstly we have to calculate the concentration of CO, the concentration of the H2, and also the concentration of the CH4 at the equilibrium. Okay, so concentration of the CO at the equilibrium is equal to 0.26 mole divide with the volume of the container 0.32 liter, then it is equal to 0.81 molar. And then the concentration of the H2 at the equilibrium is equal to 0.091 mole divide with volume 0.32 liter, then we'll get and lastly the concentration of the CH4 at the equilibrium is equal to 0.041 divided with 0.32 liter, so it is equal to 0.31 molar. Okay, now we have to use the Kc expression. Okay, with the Kc value that is given, Kc is equal to H2 power of 3 multiply with the CO power of 1 over concentration of the CH4 power of 1 multiply with the concentration of the H2O power of 1. So we want to calculate this, the concentration of the H2O. So make it as a subject. So H2O concentration at the equilibrium is equal to the H2 power of 3, CO power of 1, CH4 power of 1, Kc, and the value is H2 is 0.28 power of 3, CO that we calculate 0.81 power of 1 over CH4 0.31 power of 1, and the Kc is 0.26. Finally, we'll get the concentration of the H2O is equal to 0.53 molar. Okay, let's look at to the next example. We have a reaction of the CO plus H2O produce CO2 plus H2. Okay, let's look at to other information that we have. We have 0.25 mole of the CO and 0.25 mole of the H2O that is placed in 125 ml of flask. Okay, so we have the amount of the CO and H2O, and then we have the volume of the flask. Temperature is 900 K, and Kc is also given as 1.56. Okay, so the question want us to calculate the composition of the equilibrium mixture. Okay, means that we have to calculate what is the concentration of the CO, what is the concentration of the H2O, CO2, and also H2 when they are at the equilibrium. And what we have here is the amount of them that is placed initially in the reaction container. Okay, so to solve this, as usual, we have to have the ice table. Okay, since that the amount that is given here is in mole, so firstly we convert it to the concentration. Okay, so that's the plan. Okay, so initial concentration of the CO is equal to 0.25 mole divided with the container is 0.125 liter, which is equal to 2. And then the concentration of the H2O initially is equal to 0.25 mole divided with 0.25 divided with 0.125 liter. It is equal to 2 molar as well. So construct our ice table. We have CO plus with H2O produced CO2 plus H2. So the concentration initial of the CO is 2 molar, concentration initial of H2O2, 0 for CO2, 0 for H2O, because only reactant presents initially in the reaction container. Then the concentration changes. Okay, so CO reactant, so it will be reduced. That is why it is negative X. Okay, negative X for the H2O, it is also reduced. And then for the concentration of the CO2 and H2, they are increased. So plus X plus X. And lastly, the concentration at the equilibrium will be 2 minus X for the CO, 2 minus X for the H2O, X for CO2, X for H2. Okay, so we have to know what is the concentration of the H2, CO2, H2O and CO at equilibrium. Therefore, we have to solve our X value first. Okay, so how to solve X is by using the Kc that is given. Okay, so Kc is equal to, referring to our equation, CO2 multiply with H2 over CO multiply with the concentration of the H2O. Okay, remember back. Okay, CO2 is X, H2 X, both H2O and carbon monoxide is 2 minus X, so that our expression will become X multiply with X, 2 minus X multiply 2 minus X, which is equal to X squared over 2 minus X. And the value of Kc just now is 1.56. Okay. Since that, okay, our right side, this side is perfect square, so that we can solve this equation only by square root. So we'll get plus minus 1.25 is equal to X over 2 minus X. So our X is equal to 1.11. So when X is equal to 1.11, then we know that the concentration of CO2, which is equal to the concentration of H2, is equal to 1.11 molar. And the concentration of the CO, which is equal to the concentration of the H2O, is equal to 2 minus 1.11. So it is actually equal to 0.89 molar.